stretches and horizontal stretches. Paying attention? So with y's, if you multiply them by -1, your positive y becomes a negative y, your negative y becomes positive y when you reflect in the x-axis, right? Remember, it reflects in the opposite axis of what it affects. And then the stuff that affects the x values reflects in the y-axis. We agree? Okay, so we know that that happens. Same thing happens with verticals. So if the vertical stretch is going to pull it higher or narrower, it's going to squish it or stretch it, right? We call it stretching anyways. But it's going to be about the x-axis, and horizontal stretches will be about the y-axis. So the great thing is, it always affects the opposite axis. Vertical stretches are about the x, and a reflection in the x. When it's negative with the y. When it's negative or a number with the x, it's a horizontal stretch about the y-axis or a reflection in the y-axis. So it's always about the opposite one. All right, so vertical stretches are in the form y equals a f of x, or 1 over a y, but you would move it over, because remember our goal is to get into y equals and a 1 in front of our x every single time before we start. Now it says a is a vertical stretch by a factor of a about the x-axis. So that's how we're going to literally write it. Vertical stretch by a factor of a about the x-axis. If this was a 6 here, it would be a vertical stretch by a factor of 6 about the x-axis. Now you might be like, I don't like that, I'm going to change it. If you change it, you lose marks. So don't. Okay? Our mapping notation, the cool thing about vertical translations and horizontal translations is we add and subtract, correct? But reflections and stretches, we multiply. So that's why stretches and reflections have to be listed first in transformations, and then translations at the end, because they're addition, subtraction, and we have to use bed maps. Multiplication, addition, subtraction. So, our mapping notation, it's an A. A's are the best. X stays the same. Sorry, it's a Y. Y's are the best. So, we're going to go A times Y. Remember, whatever it is in the equation for Y's, it stays the same. If it was a negative A, it would still be stretched by A. The negative is a reflection. So your stretches are always positive. If it's a negative number, it's a reflection as well. So you get two things. So the points on the x-axis are invariant. And the reason why they're invariant is if I had a coordinate here and this coordinate was 2, 0, my mapping is xay, correct? So it would be xay. So xy would become xay. Well, if I put this in, it'll be 2, 0 will become 2 and then a times 0. What's anything times 0? 0. So this is still 0, correct? So it's invariant. So when you are just multiplying your y by something, wherever y is 0, it will stay the same. Because when you multiply anything by 0, it stays. Yes? Makes sense? All right. Okay, so let's discuss this one. We're going to describe the transformations. I always write them in SRT, S-R-T, stretches, reflections, translations. If you're missing any of them, you just don't write them. Like if you only have stretches and translations, you just write stretches before translations. The catch is that reflections and stretches both multiply. So they can be written reflection, stretch, translation as well. So if your brain falls out of your head, write them in alphabetical order. R-S-T, reflection, stretches, translations. I'll always go stretch, reflect, translate, because it's just the way we talk about them. But if you listed it on a test or on the diploma in RST, reflect, stretch, translate, it's still right. Because reflect and stretch are both multiplication, so they can be done in any order, right? But then the translations have to come last because they're addition, subtraction, bed maps. All right. So, describe the transformations that occurred to the original graph of y equals negative 4 f of x if it was y equals f of x. You will learn to celebrate when the original is y equals f of x. Because that means the original had nothing on it. So everything that they list is something. Some sort of stretch, reflect, translate. So we have it in y equals, and we have a 1 in front of our x. True? If we have that, we can state our transformation. I have a negative 4 in front. Is it with the x? Here's my x. Is it with the x? No. So x's be crazy. We talked about that already, right? Nothing's happening to the x's. Y's are awesome. Y's just stay the same. So this affects the y. So it is a vertical stretch by a factor of what? And it can't be negative. Factor of what? Y's never change. 4. About the, if it's vertical, it's about the x-axis. So it's about the opposite one. So if it's affecting your y's, it's about the x-axis. That covers the 4. What is the negative? We talked about this yesterday. Reflection in the x-axis, because it's applying to the y's. If it applies to the y's, it's about the other axis. So it's a reflection in the x-axis. So it's because when it affects y's, like say I stretch my y and it gets taller, it's about this axis. Or I reflect, if this can be positive, now this can be negative, that's the x-axis that it affects. X is, if it's negative, then it's positive, it's going to be about the y-axis that it reflects it. So it's always about the opposite axis, because that's what happens when you apply it to x's, or what happens when you apply it to y's. So we have words and mapping to equation. You have it at the top of your page. I'm just writing it down here. Okay? This is for x's, right? What happens to y's? They stay the same. Y's are the best, right? So when I go to do mapping, I'm going to go x, y becomes nothing to my x. And what number do I have here? -4. -4y. That's it. Okay. This one, we're given the graph of y equals f of x, and I want you to use the table of values to sketch. You can either use table of values or just coordinates. So I'm going to use these 4 coordinates off of here. But first I need to do my mapping. It's in y equals, and I have a 1 in front of my x, correct? What does this 2 affect? Y's or x's? Because it's not in the bracket with the x, it affects the y, right? Very easy to tell if it affects the x's with them. And if it doesn't, it's not. Right? So our y value is 2. That's a vertical stretch by a factor of 2. So we're going to go x, 2y. So all my x's are actually staying the same, and my y's are being doubled. Correct? So I have to go pull my coordinates off of here. I have -2, 0. I have -1, 2. I have 0, 5. And then I have 4, 0. So you find the new points, plot them. -2, comma 2 times 0, which becomes -2, 0. What is that coordinate? Starts with an I. It's invariant. And it stayed invariant because the only thing that's happening is then multiplying my y's by something. So wherever the heck my y's were 0, she ain't changing. Right? So I know this bad boy is staying. And so is this one. Right? And they're my invariant ones. So -1 is going to be 2 times 2. So it's going to be -1 and 4. And then 0, 5 is going to be 0 and 2 times 5. So 0, 10. And then that one stays. So I'm going to put this and go like this and write. Okay, we are now going to put down our pencils and listen. Okay? I will give you time, I promise, to copy down the domain range when we're done. I won't move on quickly. I will wait till every pencil is written and flips the page. I promise. So when you're done writing that down, put down your pencils. Okay? Because I want all of your attention. Because in grade 10, when you're taught domain and range, most of you have no clue what you're doing. It's like this concept that makes no sense. You're kind of lost souls at the end of it. But you just conform to whatever the heck ways they taught you, and you kind of rinse and repeat and try and do that on the test. Then in grade 11, you really only do domain and range of like absolute values a bit and parabolas. So if you memorize that it's XER, you're golden. But do you understand why the heck it's XER? Man. Also, if it's a word problem on a parabola, for example, and it went on a time continuum, like, you know, like when they throw a football and a football lands, well, time is 0 and then it lands in 5 seconds, that's not XER anymore. That's between 0 and 5, right? There was a limited domain last year. Started talking about that. But it's very minimal. This year, we do transformations in this unit. And you're like, oh, I can't wait for them to be over. Cool. Wait, they don't go away. The only unit that doesn't have transformations in it is perms and congs, and we did it already. You are welcome. So we are going to move on to polynomial graphs after this. Polynomial graphs are linears and quadratics, which we've talked about in grade 10 and 11. And then in grade 12, we do cubic, quartic, and quintic, which is 3, 3, 4, and 5. Trust me, it's the unit that most people like. It's the easiest one. I do not lie. It's your next one. Okay? Then after that, we move on to 3 chapters of trig. Yay! One of those chapters is trig graphs. So we have to be able to draw a sine graph and cos graph, and most people don't like trig. Some people do. Most do not. After that, we move on to exponential and logarithms. We have to look at exponential graphs and log graphs. After that, we move on to radicals, graphs, rational graphs, and then we move on to our last chapter, which is adding, subtracting, multiplying, dividing, and composing 2 graphs together. Graphs don't go away. So if you're like, oh, I'll just do better when I'm after this year, don't go away. Again. By the end of the year, most people find transformations quite easy. But I don't want that to be by the end of the year, right? We want you to know that right away. So I said today we're doing stretches, tomorrow we do compositions, or tomorrow we do putting them all together, combining the transformations, correct? And I told you, if after tomorrow's class you are still lost, or you're flipping when you shouldn't, or you don't know actually when you should flip or not, that's the time where you need to talk to me, okay? Because there's no better time than the present. After that, we only have inverses, and then your unit test will be the next week. So what happens on Monday is I will move on to the next unit. Your unit test will be on Thursday, okay? On Tuesday, you'll have a little major quiz to see. We'll only get one in transformations. Thursday will be your test. I move on. You know how teachers have been able to review for you in the past? 11 units, 16 weeks. I don't have the time. So instead, I made review podcasts. So you can watch the review podcast on each unit. Okay? There is one for both. There's questions you do. You try the questions first. Then you watch the podcast. You can scroll past me. See if your answer's right. If your answer's not right, scroll back. Put me on 1.5 times the speed and watch. Okay? You get it right. Ignore me. Move on to the next question. Scroll. You get it right. Scroll. You get it right. Scroll. You get it wrong. Scroll back 1.5 times the speed. Listen to me talk fast. You know what I mean? So that's where the podcast review comes in handy. I will post those tomorrow. So you'll have them plenty of time ahead of time if you want to. Okay? We keep moving on. It's just the way it is. But the reason why I put the test on Thursday instead of on Tuesday, which would be right after, is because then that gives me 4 days of reviewing with you. Transformations. Beginning of class each day. Review, 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 review. Some people need the extra 4 days. So we do like the review questions at the beginning of class, but I'm not going to do like a full review class. Okay? So if I bump it while we're working on polynomials, then we can actually practice those transformations. All right. Okay. So our domain. Paying attention. Remember, you don't need a pencil. You're just watching. The domain, there's set notation and there's interval notation. And you need to be able to know both because they can ask for both. Okay? Set notation uses what I call the squiggly brackets, aka the curly brackets. Okay? Why? Well, set notation has to, you're going to get to write this all down after. Remember, we're not, because when you write, you guys don't pay attention because you get behind me. So we're not writing this down. I promise at the end I'll stand here like this until every pencil has completed the writing. Promise. Set notation has the word set in it. And guess what the squiggly brackets or curly brackets mean? If you have an open one and you have a closed one, in mathematics, those symbols mean the set of. Hence why it's set notation. The set of. That's what, if you have one squiggly bracket, they'll mean it. You have to have it open and a closed. It means the set of. Now, for this equation, our x values are x. If this was a t, I would have to put a t here. But it's an x, so I get to put an x. Right? So you have to look at what the variable is that stands for domain. So we go x, and then we go straight up and down line. That straight up and down line in mathematics means such that. I'm not making this up. Wish I was. I'm not. So it means the set of x values such that. The reason why I have to state this is I need to tell whoever I'm talking about the domain that we are dealing with x values as domain, because your x value could be a t. It could be a smiley face for all that matters. Whatever the heck that letter is, I have to put here. So I'm telling you that this equation contains x values, not t's. Like, you know, when you did t with the football, you use t for time. Sometimes h of t was the equation. Same thing. So we have x, right? Now, we need to go from low to high. What's our lowest x value? -2. So I like truck along. I'm like, no graph, 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 no graph. -2. Graphity, 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 4. No graph, no graph, no graph, no graph. So what are my values between? -2 and 4. We agree? So then, you're just paying attention. We're not writing, but we are paying attention, right? Okay. So we're going to go -2. We put an x in the middle. We put 4 here. And then we do less than or equal to signs both. So we go low to high. So some people are like, but that makes no sense. We can't be less than this and less than this. It's not that. You're reading from the x. So when, if the, you know, they're like, eat the bigger number, alligator, yeah. So if it's open to the variable, it means greater than. If it's close to the variable, it means less. Okay? So I read from the variable. X is, it's open to it, so x is greater than or equal to -2. And it's close to this, x is less than or equal to 4. You see I'm reading from the x? Yeah. It's why the inequality signs are the same. It goes less than, less than. Because it's not actually a less than. X is greater than this, x is less than this. Do you know why you follow behind with XER, or is this just trust? I trust my teacher, so I do. Everyone knows what the R stands for, yeah?
Doesn't it mean it's including all the numbers in between?
Yes, it's real numbers. So if you don't specify what this is, this could be integers, correct? And then that would mean that I have the -2 dot, I have where it's 1, I have where it's here, 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 and then I wouldn't connect them. They would just be dots, because that would be the integers, correct? So, if your x values exist everywhere, so like it's consistently drawn, I don't pick my pen up, right? I put my pen down, I draw, I stop. If I never pick my pen up in the middle, it's XER, because it's every real number in between. That's how you get the connecting happen. If at any point in time you pick your pen up, and you start again, so if I went like this, pick my pen up here, pick my pen up here, pick my pen up, those would be integers, right? Probably like 1, 2, 3. So it does matter. And it changes in calculus too. It's not always reals. For us, it often is. Okay? So that's set notation. Interval notation is easier because you just do square bracket, square because it's equal to, round bracket if there wasn't the equal to sign. Remember that? So it's going to be a square bracket on this side, square bracket on this side, and a comma in between. This dot isn't real. Ignore that. And then you go low to high, 2 to 4. If it was XER, it would be -infinity to positive infinity, round brackets, because round bracket means you can't be equal to. You can't equal a concept to it. -infinity, yeah. -infinity is a concept, infinity is a concept. It's not like it's 100. It's just like, because I'm brother. So you have to have like round brackets. Okay? So let's talk about the range. So I'm talking about the y's, and it is y. So that's good. I can still use y's. I don't have to use h of t as my variable, right? If it was h of t equals, I would have to go squiggly bracket h of t such that, and put h of t in the middle, because that would be the variable. Okay. Walking along, no graph, no graph, no graph. Graph starts at 0. Graphy, 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 graphy. Ends at 10. No graphy, no graphy, no graphy. What are my y values? 0 to 10. Do I pick my pen up at all? No. So it's going to be y's, because it's y, such that 0 is less than or equal to y is less than or equal to 10, which seems stupid, but you read from the y. Y is open, so y is greater than or equal to 0, but y is less than or equal to 10. Y, E, R, squiggly bracket. And then here it would be 0 to 10 square brackets because they're equal to. You may pick up your pencil. Righty, right. Okay. Horizontal is x's, right? X's be crazy. Yes? So we are going to talk about this as an equation. Okay, do you see that? So we're going to go from equation to words and mapping. And so we're talking about x's now, and x's be crazy. Okay? So if our equation is y equals fb of x, this is where you guys start falling apart. Because you don't know when to keep and you don't know when to flip. Don't fall apart. Use the diagram. I came up with this diagram about 1.5 years ago because I was so sick of everyone not knowing when to flip and not. But I feel like this has made it better. So you, please, adapt. So we're going from an equation to speaking, correct? Equation to words. So my x's are going to switch. Whatever they are, they're going to switch. When it was x minus 2, we went 2 to the right. When it was x plus 2, we went 2 to the left. Okay? If it is b, it reciprocates. It becomes 1 over b. So if it was 4, it becomes a 4. If it's 10, it becomes a 10. Do you think they're going to have the answer to a horizontal stretch by a factor of b and the horizontal stretch by a factor of 1 over b as the two multiple choice answers? Yep, there they are. So if you don't know when you switch or when you keep, you're in trouble, which is why I said the test is really bad. You don't know because all your answers are there. The oopsies and the not oopsies is there. So if this is a b, it's going to be a horizontal stretch by a factor of 1 over b about the y-axis. Then we're going to go into mapping. So when we go from words to mapping, they're in a heart. True? We're in the middle of the page. So words to mapping, you bypassed that. I said that. So fine. It's okay. So words and mapping are in the same heart. Yes? So if we're horizontally stretching it by 1 over b, what are we multiplying by? 1 over b. Yes. Words and mapping, same. The words say 1 over b. The mapping says 1 over b. Yes? Yes, they do. So it would be 1 over bx, y. Do you want to know how officially old I am? I'm a great aunt. Great. So, this would be the same where when we were stretching a y, if y was 0 and we multiplied it, it stayed, correct? Now we're stretching an x. So if x is 0 and we multiply it, it's going to stay the same. So for these ones, the invariant point is on the y-axis because that's where x equals 0. If b is a negative sign, just like before, it's not a stretch, it's a reflection, correct? So don't say horizontally stretched by negative 1 over b. It'll be 1 over b, and the negative's a reflection. So it's two things happening when you have a negative. So let's look at this first one. Describe the transformations that occurred if the original graph of y equals f of 5x was y equals 5x in state mapping. So we're in y equals, now some people will say to me, Mrs. Lepp, there's not a 1 in front of the x, that's a problem. Okay? If all it is no translations, you're fine, because we could go 5 times 1x technically, couldn't we? 5 times 1x is 5x, yes? Yeah. So if all it is a stretch, you technically are okay to not put 1 in front, but if you really want to, you could go 5 times 1x, okay? So if all it is a stretch, you can get away with there being a number in front. But if it was like this, watch, 5x plus 25, people are going to tell me that it's a horizontal stretch by a factor of 1/5 and then horizontal translation 25 left, when in reality, you have to remember to take that out. right? So it's actually 5 left. So you're going to get your horizontal translation wrong. So as long as there isn't a horizontal translation there, then it doesn't matter what that number is in front to like have to take it out. Because there's nothing to take it out of, it's just a 5 and an X. All right. So we're going from equation to words. So this 5 is going to turn to a what? A 1/5. So we're going to say horizontal stretch by a factor of 1/5 about the x-axis. And I lied, about the y-axis. It has to be about the opposite one. It's not that bad. And then xy becomes, I'm doing words and mapping. Words and mapping. In a heart. Words has the number 1/5. Mapping has the number. If words is the number 1/5, mapping is the number 1/5. Words and mapping in a heart. Yes. Stays the same. Whoop, whoop. That's not exciting. Okay. 1/5 x, comma y. Good talk. All right. Go. Go team. Try that question. So, our x values fall between what and what? What do our x values fall between? -1 and 2. So in interval notation, because it's a closed dot, it would be -1, comma 2. In set notation, it would be our variable is x, our other variable is y, so we're still good. X such that -1 is less than or equal to x, is less than or equal to 2, comma x e double r. Okay. X is greater than or equal to -1, x is less than or equal to 2. We're reading from the x. That is why they're in the same looking inequality signs, but they mean opposite. Because you read from the variable. From the variable. Okay? Okay. Our range is 0 to 5. Did our range change? No, their y didn't change. So it's going to be y such that 0 is less than or equal to y is less than or equal to 5. Y. Oh boy. Okay, then we're going to flip over. So, remember how I told you when you see y equals f of x, be excited, because that means you got an original function that has nothing happening to it. But what happens if you're not given that? So describe the transformations that occurred to each, if the original function is y equals 4 minus x cubed. Everyone paying attention? Then state mapping. So this is what the original had. This is what the new still has. So did any of that change? No. So those of you who are like, it moved 4 up, there's a reflection in the y. No, it didn't. That was there, and that is still there, correct? What's the only thing that did happen? There's a 3 decided to show up to the party, okay? Now we have to decide, is that 3 with the x? No, so what's it with? Yeah, that's it. That's like literally as hard as it. If it's not with that x, the x, it is with the y. Boom, cool. Okay, it is a 3. X's be crazy. Y's be awesome. Yes, Y's just stay the same. So if it's a 3, it's going to be a 3. That only works though if you have it in Y equals, correct? So this is a vertical stretch by a factor of 3 about the x-axis. And then our mapping is going to be 3y, because y's do not change. B throws people for a wee bit of a loop. We have 4 minus x cubed Now we have 4 minus x cubed. 7 happens to have a 2 in front of x. Yeah? The 2 is in front of the x. Yeah? The 2 is with the x. So does it affect the x? Yes. X's be crazy. So I have to decide. This is going from an equation to words and mapping. Equation to words and mapping. What happens between equation and words and mapping? Flips. So it is a 2. It will be a 1 over 2. Thank you. Thank you, baby Jesus. Okay. Horizontal stretch by a factor of 1/2 about the y-axis. Fully supported. Okay. So, in words, listening? In words, we have 1/2. In mapping, we're going to have 1/2 because mapping and words are in the heart. Same, not different. Words be a half, mapping be a half. Okay? XY becomes 1/2 x y. All right. Next one. It says, describe the transformations that occurred and state the mapping if the original function was y equals x squared. Okay? Paying attention? The bracket is here if there is no bracket on the x, yes? True? Okay, if we look at A, you guys will pull me over on a test and you'll be like, well, is this horizontal or vertical? And I'll be like, where are the brackets? You're like, they're here. So it's horizontal. And I'm like, did you draw the brackets or did I draw the brackets? And they're like, I did. So it's horizontal. And I'm like, did you draw the brackets or did I draw the brackets? You're like, I did. So it's horizontal. And I'm like, did you draw the brackets or did I draw the brackets? And you're like, I did. So it's, I'm like, you drew the brackets. You made the brackets around there. If the brackets don't exist, where can you draw them? Around the x, that's it. You can draw them wherever the heck you want and be wrong, but that's an eraser. They're here. Yeah? If it's with the x, they have to draw the brackets around those. Yeah? Yeah. Okay. What is currently with the x? 1. So basically nothing is with the x. So is anything affecting the x's? No. Throw a party because it's all y's and y's be nice. Yeah? Okay, so let's try this out. Vertical stretch. Okay. Shh. Vertical stretch by a factor of what? 2. Not -2. About the x-axis. Do we have to go to the equation words mapping diagram when it's y's? No, because that's only for x's. Y's never changed, right? If there's a negative in front of it, what does that mean? Reflection in the x-axis. He is. Someone's been doing his homework.
I did do my homework.
That is the point. See? It works out. What does the +3 at the back do? Kind of.
Vertical.
Yeah.
Translation for units up.
Yes. Vertical. Translation. 3 units up. So we're going to do x, y becomes, y's are the easiest. Multiply this, add that. It doesn't change, right? So x's stayed the same. There's nothing in the bracket. My y becomes -2y plus 3. Voila. You can see how this can go good or bad? Yeah, it's very easy to go really well or really badly. I pray for really well. Okay. B. What be our problem?
With what? With X.
Yeah, it's with the X. That's the problem. We have a what in front of it? There's a -2 in front of it and a horizontal translation behind it, right? So we have to get a 1 in front of our X. So we have to take that -2 out. Oh, there's a breeze. Thank you. -2x, take out a -2 is x. 4 divided by -2, because when you put it back in, you multiply. So taking the GCF out is dividing. 4 divided by -2 is -2 squared. So it's actually a horizontal translation 2 right, not 4 left. Do you think 4 left will be there on the test? Yes. Do you know what else will be there? 4 right. So you're totally out to lunch. You forgot to take it out and you took it the wrong direction. So every oopsie is on your test. Because it's not going to be like the correct answer and then pig, puppy, bunny.
Why not?
It's not going to happen. Okay. So, this be the x's. The x's decrease. We're going from equation to, where's the mapping? Equation to, where's the mapping? What's going to happen to our x's? They're going to be crazy. They're going to flip and change. All right. We have a horizontal stretch by a factor of what? 1/2 about the y-axis. Then we have the negative involved. What is that? That's a reflection in the y-axis. I don't hear the rest of you answering anything. Oh. What is the last one? Horizontal translation. 2 units. Right. Oh boy. Okay. Now what we have in words and mapping. Nothing's happening to my y. It's just going to stay. In words, I have a horizontal stretch by 1/2. So in mapping, I'm going to use 1/2 because they be in the same heart. Yes? And then the reflection makes that 1/2 be what? Negative. So we know we have a -1/2 x. And then I need to move 2 right. Plus 2. Yep. Okay? Because there's a -2, there's a reflection in the y-axis. So the negative stays negative. It's the only thing that doesn't go crazy. It flips that close. Yeah. All right. I'm going to give you the last part of this class to flip to the stretches homework and start working on it. If you have not done the translations or reflections at all, and now not stretches, I'll just say a little prayer for you tomorrow. But remember, God can't help you if you don't help yourselves. So you need to do some of the work.